Hello children, hope you guys are fine and are staying safe at home. So welcome to yet another class. So we are going to have the third class in science, that is the chapter from the chapter motion and measurement of distances. So I hope you guys would have understood the previous two classes which we have dealt. So now, before we enter into another topic, I would like to conduct a small test for you. Okay, so here are a few questions for you. Just try to see this question, read this question, and try to analyze the answer on your own. Okay, so the first question is 1 meter is equal to dash centimeter. I hope we have discussed this in our previous class when I was telling about how to measure the length of an object, right? So what is the answer? So option A 1 centimeter, option B 10 centimeter, option C 100 centimeter, and option D 1000 centimeter. So shall we find out the answer, children? Is it option A? No, it's not option A. Is it option C? No, it is not option D as well. It is not option B as well. Then what is the final answer actually? It is option C, 100 centimeter. Fantastic. Now let's move on to the second question. Dash is the unit to measure the longer distances. So which unit we use to measure the longer distances? Is it meters, centimeter, or kilometer? Yes, so we use kilometer, which is the unit to measure the longer distances. Like if you want to measure the distance between one Embadi and Chennai, or one Embadi and Ambur, wherever. So which unit we are using? We use kilometer. The third question, we use dash scale for measuring length. So this is a very simple answer. Which scale we are using? We usually use meter scale to measure the length of any object. Okay, now let's move on to a quick recap of what we have learned in our previous class. This is very important, right? Now, what are all the things we learned in our previous class? We learned that people used to measure using body parts for measuring the length, breadth, and height of different objects. So as I told you guys already, so before the advent of any meter scale, so people, what they were doing, they were using their own body parts like hand. Okay, mostly they will use hands to measure the length, breadth, or height of different objects. So I gave a lot of examples by using hand span. Okay, and also a lot of techniques used by military people, that also I have shown in the previous class. Then for the sake of uniformity, what was brought? We brought a standard system of unit. We denote it as International System of Units, that is also known as SI units. And then the unit of measurement of SI unit, the common unit for measurement of SI unit is meter. So for longer distances we need to measure using kilometer. So these units will vary according to the measurement which you are doing. Okay, now let's move on to the next part of the chapter, that is the motion and measurement of distances. So in our today's class we have got some two learning objectives. Okay, so first thing is, in the previous class we learnt about how to measure the length of an object. Okay, so in general we learned, but today we are going to learn specifically about measuring the length using a curved line. In case you have any objects which is not in a uniform shape, so if it is in a curvy shape, okay, so how do we measure the length of any object which is in a curved shape, or how do we measure a curved line? Okay, so that we are going to learn today. And at the end of this lesson you guys will be able to understand about measuring the length using curved line, as I said earlier, and also about moving things around us. Okay, so this is a new topic which we are going to discuss. So what are all the objects which can move from one place to another place? Okay, so let's move on to this chapter, children, shall we? Yeah. Now, the first thing, as I said, measuring the length of a curved line. So how do we measure the length of a curved line? Do we have any specific meter scale through which we can measure the curved line? I don't think so. There is any flexible scale available. Even if it is available, we cannot bend it in different shapes so that we can measure a curved line easily, right? So what do we do at that situation? So we need to measure the curved line using a thread and a ruler. So in case, for example, as you can see in the picture, if the line is in the form of a curved shape, so we cannot keep a straight scale, meter scale, which is usually in a straight line form. So we cannot directly keep the meter scale and say, okay, this is 10 centimeter in length or 15 centimeter in length, etc. So at that situation, what we need to do is we need to use a thread and we need to mark different points, okay, where the edges are getting turned. Okay, so wherever there is a turning, so what we need to do, we need to mark that particular area and then we have to measure finally using a meter scale. Okay, so now I would like to show you a small video where you can able to understand actually how can we measure the length of a curved line. Okay, so watch this video carefully, children. Okay,
measuring the length of a curved line. The length of a curved line can be measured by using a thread. Put a knot on the thread near one end. Place the knot at the beginning of the line, point A, and press it with your thumb. Place a small portion of the thread along the curved line. Press the other end of this portion with your forefinger. Now place the thumb at point B and a small portion of the thread along the next portion of the line.
So you can see here, so the point A is the starting point. We have to denote it as point A, and after each turn, okay, again when it reaches back to another turn of this curved line, so that you have to denote it as point B. So like this, what you have to do, you have to place the thread, okay, according to the line, according to the curved line. So for the next position also you need to follow the same steps. So at the starting point, place your thumb, and at the half of the point where actually it bends, the curve bends, there you need to hold the thread by using your forefinger. And again when it reaches the bottom, again when a new curve starts, at that position you have to denote it as point B. There also you should keep your another thumb. Okay, so like this you have to keep on measuring the or keep on placing the thread using the curved line. Okay,
repeat to trace the entire length of the curved line using the thread. Mark the thread where it touches the end of the line. Now stretch out the thread on a meter scale and measure its length. The length of the thread is the length of the curved line.
so finally what you need to do after tracing this curved line, okay, so mark the final position where the curved line ends. Okay, so mark that position on the thread and then take out the thread completely, make the thread straight. Okay, and now place the thread in the meter scale. Now you can able to easily determine the actual length of the curved line. So this is how we need to measure the length of a curved line. Okay, so we cannot directly place the meter scale and say this is okay, this much of centimeter. For that purpose, what we have to do, we need to use a thread and you need to trace the whole curved line. Okay, and then finally when it reaches the end point, you have to take out the thread, make the thread straight and then place it on a meter scale. So this is a simple way with which you can measure the length of a curved line. So I hope you guys would have understood how we can able to measure the length of a curved line. Okay, now let's move on to another topic, that is moving things around us. So what do you understand by moving? Moving means moving from one place to another place, right? So that is what is the moving things around us. Now I'll show you some pictures. Try to identify whether these objects can move from one place to another place. So what is this actually? It's a specs, okay, spectacles which you used to wear in your eyes. Are these things movable automatically? No, right? So this particular thing cannot move on its own until and otherwise we place it from one place to another place. So what is this actually? It's a home. Can we able to move our home from one place to another place? No, right? We only have to move. Your house cannot move from one place to another place. What is this actually? It's a desk, and somebody, lazy student is sleeping over there. Can this desk be moved? We cannot move automatically unless and otherwise somebody is moving it. What is this, the fourth one? It is a sofa. So sofa also cannot move from one place to another place. So all these objects can we consider it as immovable object? Yes, absolutely, these are immovable objects. Why do we call these objects as immovable objects? Because they cannot move automatically, like how we walk and move from one place to another place automatically, or like how birds fly from one place to another place automatically. The same way, these objects cannot move automatically from one place to another place. So can we consider these objects as objects at rest, right? So if an object is placed in a particular position for a long amount of time, then we can call these objects as these objects are at rest, right? So because until and otherwise we don't disturb these objects, they cannot move automatically from one place to another place. So we can denote these objects as objects at rest. Okay, so what about let us see few more examples. So what is this actually? So this is earth is revolving, some rockets are flowing, okay, and moon is also revolving around the sun. Okay, so are these objects are moving? So revolving is also like moving, right? So earth daily it revolves around the sun, moon also it revolves around the earth, okay, and the sun. So these objects are considered as movable objects. Okay, what about birds? As you can say, birds can fly automatically from one place to another place. So we can consider birds also as a movable object. The clock, usually whenever you see the clock, the seconds or the minute needle of the clock will always move. Okay, so seconds needle of the clock will always move, and that's the reason why the time advances, right? So we can able to say, okay, 1 minute, 2 minutes, 1 hour. Okay, so always the hour and minutes needle moves because the seconds needle in the clock always keeps on ticking. Okay, so this can also be considered as a moving object. So what about this? It is ants. Ants are actually moving, right? So can we consider them as the objects in motion, right? Because those objects, the previous one which we saw, like table or a chair or maybe spectacles or whatever you take, those objects, they are not moving automatically. They are in a stationary position. Stationary means they were at rest. They were just simply placed in one area and they are remaining quiet. They are not moving. They are not doing anything. They are not performing anything, right? So they are like statues, we can say. So all those things are actually are at rest. Those objects are at rest. But these are the objects, even though they are also non-living, few of them are non-living things. Like if you take clock is a non-living thing, but then the seconds, okay, needle of the clock keeps on ticking and it shows us the time, the correct time, right? So these objects are actually moving automatically once some sort of force is automatically being applied. Okay, so we can consider these objects as objects in motion. Okay, now what do you infer from the previous examples? What does motion refers to? So what can we conclude from these examples? So from these examples we can actually define what a motion actually is. So a motion is nothing but it seems to be some kind of a change in the position of an object with time. What is actually motion? So when do we call an object in motion? It is nothing but the change in position of an object with respect to time. So if an object is moving from one place to another place with respect to time, we can call it as motion. That is the reason why we have when the earth rotates, okay, completely, okay, so the earth spins on its own axis. So 24 hours, how do we calculate? So for one complete rotation, how much time it takes? It takes 24 hours. And one complete revolution, okay, it takes how many days? 365 days. That's the reason why we count it and tell that it is 1 year. So depending upon its revolution, depending upon its rotation, we calculate the number of number of hours, which denotes the day, and also we calculate the year. So that varies according to different planets based on their orbit size. The same way, not only that, any object which moves, like for example, we can also even calculate the time of traveling. We can assume and calculate the time of traveling. For example, if you want to travel from Vanembadi to Ambur, right? So you can guess and say, okay, within half an hour I am able to reach from Vanembadi to Ambur using my bike. So how do we calculate that? We calculate based on the speed. So what is that speed actually? It is nothing but the motion, right? So with respect to time with which an object moves, we can calculate and we can consider it as a motion, right? Now all these are examples for motion, that is the clock which is ticking and the fan which is running and the train which moves. Okay, now here you can see these are all few more examples of an object which can move automatically. As I said earlier, this clock also, the seconds needle keeps on ticking and it will tell you the exact time. Okay, and the fan, when it rotates, the fan needle will keep on spinning, right? Okay, and we can able to say that the fan is in motion. If we stop the fan, then we can say the fan is at rest. So keep that in mind. When it is keep on moving, we can say that it is in motion because the fan keeps on moving with respect to time. The same way, when a train moves from one place to another place continuously, we can say that the train is in a motion. The train is moving, right? When it stops, then we can say, okay, the train is at rest. That object is at rest. So how do these objects move? So these objects move with respect to some sort of force. Okay, so when we apply some force to them, okay, it can be any force. It can be kinetic energy, or it can be heat, or it can be light, or whatever. Okay, depending upon gravity, whatever, any force. Okay, depending upon different types of force, an object can move easily from one place to another place. Okay, so with this, I would like to stop today's session. So before we close our session, so let's do a quick recap of whatever we have learnt today. Okay, so what are the things we learned? We learned that which object is used to measure the curved line. So we use thread to measure the length of a curved line. This is very, very important. So you can also try it at home. You can take any curved line, curved object, and then you can place the threads, and then finally mark the initial position and final position. Take out the thread and measure its length. Okay, then when an object is in idle position, idle means what? When it is not moving. Okay, then it is also called as object at rest. Okay, as I said, if a fan is moving, then we can say object in motion. If a fan is not moving, then we can say the object is at rest. What is the third point I said? As I said earlier, when an object moves, it is termed as object in motion. So whenever an object moves from one place to another place with respect to time, then we can say that the object is in motion. Okay, now here is a quick assessment for you, okay, to check what you have understood in this class. Okay, so here are few questions for you. Identify whether the object is at rest or in motion. So here are a few pictures for you. Okay, so go through these pictures and try to mark whether the first object is moving. I mean whether these objects are moving or at rest. Okay, and for this assessment you can have a separate note for science. Okay, and you can try to write the answer on your own, and then you can submit it in WhatsApp group. Then you have got a home fun for you. So the home fun is, try to analyze why could you not use an elastic measuring tape to measure distance. As I said earlier, today I explained you how to measure the length of a curved line using a thread, right? The same way, can't we use elastic measuring tape? Elastic means, you know, right, which can easily bend. That is what is not only bend, we can which can be easily stretched, not bend actually, it can be easily stretched. That is elasticity. So we can try to use elastic tape, right, because it can be stretched to measure the long distance. So can be able to measure the longer distance using elastic tape. So what would be some problems you would meet in telling someone about a distance you measured with an elastic tape? Suppose if you try to measure the longer length using elastic tape, okay, what can be the errors which you will get, and or the difficulties which you will face while measuring using elastic tape? So try to think this, try to analyze this and find out the answer on your own. Okay, and write it in your homework notebook, and you have to submit your answers in the WhatsApp group. Do not try to copy the answer from the book or anything. Okay, try to analyze on your own, because this is something like a higher order thinking skill question. So try to think on your own, try to analyze on your own, and whatever comes to your mind, okay, you can present the answer, okay, on your own and submit it. Okay, hope you guys would have understood my today's class. So till we meet next time, take care children, have a good day. Thank you.